Hello, let's continue our Sudoku adventure with Entropical Regions by GDC. So we have normal 6x6 Sudoku rules, meaning in each row, each column, and each 2x3 box, we are placing the digits 1 to 6 exactly once each. We also have duality here, which is telling us that all of our lines are both region sum lines and entropic lines. So they fit both standards, which is why we don't just combine those rules. But both rules have to be obeyed. Now, region sum lines, the way these work is you look at where the box borders are, and that splits the line into segments. So this is a single segment, I'll call that green. This is a segment purple, and this is a segment blue. So even though these are in the same box, because we leave the box and come back in, we cross this box border both times, it creates a new segment. Now, the sum of the segments on, the sum of the digits on each segment is the same. So if this was, say, a 5, that would define our sum. Our sum would be 5. We could do, say, 1, 4 here and 3, 2 here. So 2 plus 3 is 5, 1 plus 4 is 5, and 5 is 5. So they'd all have the same sum. But the sum doesn't have to be 5, right? That's just an example. Now, the sum of segments on different lines can be different sums. So don't get confused there. It's just within the same line, all the segments have the same sum. In addition to that, all these lines are also entropic lines. So what we want to do is look at any group of 3 adjacent digits on the line, and one of them will be low, one will be medium, and one will be high. Low being 1, 2, medium being 3, 4, high being 5, 6. And so that's true of all groups of 3. So these three, and these 3 follow that. So if this was, for example, a 3, within this group of 3, that would use up our medium. So we're not allowed to put another medium because we need to have a low and a high. So now we could make maybe this one the high as like a 6, and this could be low as a 1. So this would be a valid way to fill these 3 cells because we have 1 low, 1 medium, 1 high. But keep in mind that these 3 also need 1 of each, and these 3 also need 1 of each. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, I do want to get started with this line here because what I'm noticing is we need 2 different ways to sum to the same digit here. So that limits it to 5 or 6 because the 4 has only one way to add to it, 1 plus 3. And the 3, it would be 1 plus 2. And 1 and 2 can't even add to in a domino. So this has to be 5 or 6, which is our high entropicity. So I'm going to use orange for that, like orange for high. Now, whatever this is, it's going to repeat here. Now, why do I know that? Well, let's just give arbitrary colors here. I'm going to give this blue and purple. And it's a gamble because usually I like blue to be low, purple to be mid. I don't know which is which right now, but we'll take this gamble. So these 3, we have 1 of each, and we're going to represent blue as, whatever this entropicity ends up being. That's what blue is. This is purple, which we know isn't blue. And this is orange, which we know isn't blue or purple. And so we have 1 of each color in every group of 3. So this group of 3 here also needs 1 of each color. We've already defined that it has purple and orange. So it needs to have a blue. And now these 3 already have orange and blue, so it needs to be a purple. So you end up cycling. And that's really important property of these entropic lines, is every 3 is the same entropicity. So we cycle blue, purple, orange, blue, purple. If there was another one, it would go back to orange, then blue, purple, orange, etc. But again, we don't know which is low, which is high. We do know these are both orange, and that means they're high. And that makes sense because we have 2 ways to add to 5 or 6. Oh, interesting. Yeah, okay. So that means we can't use the 5, which means that we can't add to 6. Because the way to add to 6 is 1, 5, and 2, 4. Since we're missing the 5, not the 3, that does make all of these oranges 5. It makes this orange 5. This is still a 5, 6. I don't know what I was talking about. That makes the sum 5. And so these are going to be 1, 2, 3, 4, adding to 5 in some way. But we don't know which is low and high yet, so we can't do more with that. Now this is the sum of these 2 and these 2. So if we think about this, this could be 1, 2, 3, and this could be a 1. And so that adds to 7. Now we know it's going to add to an even number, so it actually adds to a minimum of 8. Which tells me that this could be a 4 or a 6. Now, can it actually be a 4? Well, let's think about it. If it was a 4, then this would add to 3, and this would add to 4, and this would add to 4. Only way to add to 4 is a 1, 3 pair. And so we actually still need 2 ways to add to it. So it cannot be a 4. So it must be a 6, and that's our high. And that makes this 5 and this 6. What's a 6 over here somewhere? So these adding to 6 means we're using the either the 1, 5 and the 2, 4. This can't be 5, so that can't be 1. And it means the 3 is not on it. Right, what about this little dude? Oh, this is also entropic, so let's think about that. So I don't know what color to give this. I'm going to use a different color. Let's use, I'm trying to decide. Let's use green and red. So I don't know what green or red is entropically, but we do know that it's going to cycle. And so actually this has to be high. We go orange, green, red, then we go orange and then green. So the only high available here is the 5. So that has to be 5, meaning this has to be 1, meaning green is low. So this is 1 or 2, and then this has to be a 4, which goes with 2. Okay, right. I knew it was going to be 2, 4. So I guess green is low and 4 is mid. Once I figure out what these are, I'll fix up the colors. In fact, I'm going to get rid of these colors until we know whether blue. You know what? I think it's better to get rid of these colors. And then now I know that this is low and this is mid, and we'll just go from there. Okay, do we want to look at this one? Because this is one of each. So if there's a low, a medium, and a high, the high is going to be the sum of the low and medium, right? So this is high, and it has to be a 6. And so now this is one of each. Okay, so that's a 6 there. And we're not allowed to use a high, so it can't be 1, 5. So it has to be 2, 4. Okay, that leaves behind 3, 5. Oh, this can't be 5 or 6. So this is where the 5, 6 go. This 6 tells us that that's 6, that's 5. These are both high. So this is a 3, which is mid. That puts a 3 down here, which is mid. We need a 5 in this box. And then this is low, it's 1. This is mid, it's 4. And this is low, it's 2. Okay, perfect. The only thing we have to really account for is the entropicity and the summation to 5 over here. Otherwise, we should be Sudoku. So we know that there's a 4 up here, and we know there's a 2 over here. What else can I do here? I have to do with... Let's actually color this. Let's reuse our red and green. So we go red, green, orange, and then we do red and then green. Because now we know this has to be red. Now, why do I know that? Well, I have both of my highs, and I have one of each of mid, low. So whatever this one is, this has to be a different one. Otherwise, we'd have 3 of it. Here, we've got both highs and a green and a red, and then a blue. So one of these will be the same as blue. So that uses up our blues, making this one mid. So it's a 3 or a 4. I don't know which. Over here, we have both of our highs used up. Now, can this be double low? Yes, this would be mid. Okay, so this could be double low. Trying to consider. Oh, the 6. The 6's help. 6 is placed here. That's orange. And the 5 is placed here. That's orange. 5s and 6s are done. Something I can do here. This is one of each, so these are one of each. I don't know. I'm going to run out of colors here. I don't know if I want to color that. What am I missing? Okay, we're adding to 5. So we're going to do 1 plus 4 and 2 plus 3. So if this was... Okay, so let's just put 1, 2, 3, 4 in. Neither of these can be 1. Oh, so then they can't be 1 plus 4. So that is 2, 3. And this is 1, 4. And we know the order, that's 1 and 4. That makes red blue. And that makes green purple. Okay, that was easy. So that has to be the 2 and the 3 because of the colors. Gives us the 2 and the 4 up here. 2 is blue, but the 3 is DT dude in the corner. I get yelled at if I don't mention that. That's a 4. It's purple. Here we have a 4 here. That's a 1. That's a 2 and a 4. Blue and purple. What do I need here? I need the 2 and the 3. So the 2 tells us that's 2 and 3. That's blue. That's purple. This row finishes with a blue, which is a 1. This row finishes with a purple, which is 3. Last colors, blue this is blue, this is purple. You get a 1 and a 3, and we're done. All right, cool. Thanks, GDC. That was neat. I don't know why it took me so long to just look at this sum again. I was convinced there was more Sudoku to do, but yeah, once I looked at how we were going to add to 5, it became very clear what had to happen. Had some fun coloring though. Cool. Well, hope you enjoyed this. If you did, then why not leave a like, subscribe, and a kind comment below.